Let's verify this following identity. All right, so we're given a pretty complex looking identity going on here. What you'll want to do is always just start with the more difficult looking side. So in our case, I'm going to visualize the left-hand side looks a little bit more difficult than the right-hand side. So let's start with it. First thing I'm going to do is think of this as just rearranging it based on, we have some exponents going on, right? So when we have sine squared of negative theta, what that really means is sine of negative theta quantity squared. Similarly here for cosine, we can say that's squared, and then our denominators, we get just copying down the exact same thing. So I haven't used any identities or anything like that yet, just rewritten it so we can see a little bit clearer vision of what's going on here, I think. Next thing I notice is we've got a bunch of negatives inside of our cosine and sine functions. Let's work on getting rid of those. So whenever you have this, we can always use our even-odd identities. All right, and what these are going to allow us to do is get rid of the negative from the inside. So one of these says sine of a negative angle, negative theta, equals negative sine of positive theta. And the other one is cosine of negative theta is just cosine of positive theta. So let's use these identities and just fill in, basically. So on the inside here, we can say, well, that is that's negative, make sure I get it right, negative sine of positive theta, minus, on this next one, still cosine of theta that's squared. For a denominator, using the same identities, we can say this is negative sine of theta minus cosine of theta. Okay, so no more negatives on the inside of sine or cosine. Next thing I'm going to go ahead and do is go ahead and bring those exponents to the inside. We want to square. What is negative sine of theta squared? Well, that's two copies of a negative that are multiplied together. So whenever we multiply two negatives together, it makes a positive. And the same thing here, when we have cosine of theta multiplied by cosine of theta, that's cosine squared of theta. Now for our denominator, I could leave it alone for right now, but I do notice that each one of those has a negative, right? We have a negative sine and a negative cosine. Let's factor out a negative 1. All right, that'll leave us with sine of theta plus cosine of theta on the inside here. All right, just because they both had a negative, that's something in common. Let's say it's a common factor. Now, we're actually not too far from being done with this, but we'd like to simplify it a little bit more if we can, so it looks like the right-hand side. I notice the right-hand side doesn't have anything squared. It doesn't have a denominator going on there. So to simplify, let's think about maybe we could do a little bit of factoring to help us out on simplifying. So that numerator has two terms, and each one of them happens to be a perfect square, right? Sine is squared and cosine is squared. And we have a subtraction in the middle, so what that helps us out with is it's a difference of squares. All right, this being a difference of squares, hopefully we are confident on our factoring of a difference of squares. What it does is you end up splitting up the first sine squared goes to sine of theta and sine of theta. And then you split up the cosine as cosine of theta, cosine of theta. You just make sure that one has a positive and one has a negative in between. All right, the denominator I'm just carrying along, negative 1. And then inside our parentheses, sine of theta plus cosine of theta. All right, at this point, you may notice we have a common factor between numerator and denominator. We have sine of theta plus cosine of theta in both places, so those will simplify down to lowest terms. Now I'm going to bring that negative up to the numerator. All right, dividing by negative 1, same thing as multiplying by negative 1. Now we still have sine of theta minus cosine of theta from the numerator that didn't get crossed out, right? Didn't make a 1. A little bit of distributing. That'll make negative sine of theta plus cosine of theta, which works out to be the same as what was on the right-hand side of the original. So flip-flop the order of these terms, and I'm going to call it a day. All right, that works out to be the exact same as the right-hand side. I just didn't rewrite them in the other order. So I hope this helps out. Take your time. Only use those math operations that actually work. But take your time. You can do this.